Hey guys, I hope you guys are doing good and staying sane in your little staycation for a couple of weeks. Don't forget, I have an online session every day at 12, so I can answer any questions you have, and then you guys can always send me a message and remind or email me with questions, okay? I don't want you guys sitting here confused. And what I'm going to do today is I'm going to show you guys how to write functions, either from a table or from a pattern. And so you're going to be able to write the equation that represents that function. Just as a heads up, you guys are going to take like a little quiz for me on Friday. And so that quiz is going to be on the function stuff you've done the last couple of days, like function notation. And then this right here. So we're going to do this for 2 days. Okay. All right. So let's say we have this little pattern here. Okay. So the, getting my pencil here. Okay, so the first stage here, and I like tables. Tables make sense to me. Okay, so we'll say that X is like the number in the pattern, like the term kind of thing. And then this is going to be our X. And then our Y is the total number of squares. Okay, so in the first stage, there are 5 squares. Well, then you notice in the second one that these little corners were added on. So now there's a total of 9. And then in the third one, we had 4 more of these here added on. So that puts us now at 13. And so hopefully you notice that the pattern is +4 each time. And I notice it in a table too. That helps me notice it a lot better as well. Okay. So this is our rate of change. The 4 represents the rate of change. If you've got an equation, y equals mx plus b, because that's how these are going to be, because you're adding the same thing every time. So it's a linear function. The m stands for the rate of change. That's what you're doing each time. So in this case, because we are adding 4 each time, the m is going to be 4. Now the b it's called your initial value, but in this case, it's when x equals 0. Well, if we look at our little pattern here, we're going up by 1s each time, but we started out with 1. Well, if we go backwards to 0 stage and we take off 4, because we were adding 4 going to the right, if we're going backwards, you're going to subtract 4, or you're going to take off these 4 to see that you originally started off with 1 little cube. So if you go backwards at stage 0, you started off with 1, which makes sense because you're going back 4. And so the b here would be 1. So when I put all of this together in this equation, it is y equals 4x plus 1. So again, the 4 because we're adding 4 each time. The 1 is because that's where you start off when x is 0. Okay, so let's keep. Sorry, I wanted to go back and say with this. All right, so then here too, it says that there are 173 squares in step 43. That means y is 173 when x is 43. So let's plug it in and let's see if it works. So y equals 4 times 43 plus 1. That's what, 172. So y equals 172 plus 1, so y equals 173, and that works. So this is just to show you like another step to kind of check and make sure you're going. So let's do another one. Oh, and it works, okay? So here, there's 87 trees in step 4. So same idea. In this is our x and this is our y. So in step 1, we have 3. So I'll just make a little table because tables make sense to me. So step 1, we have 3. Step 2, you can see that this 1 more was added. And so now there are 5. I said 1 more was added. 2 more was added. Sorry, 2 more was added. So now there's 5. Let me draw it the right way. There we go. And then here on stage 3, we have 2 more that were added. So now there are 7. So when we look at the pattern, we see that we are adding 2 each time. So in the equation, y equals mx plus b, the m is 2 because that's what we are adding each time. Now the b is when x is 0, so we're going to have to go backwards here. So if we take off these two and we go backwards, when x is 0, there would have been one little tree. Okay, so that means that our b is 1. So our equation here is y equals 2x plus 1. We started with 1, our initial value is 1, and we're going up by 2 each time. And then just to kind of check this, that's our y and that's our x. We'll see if we plug it in. 2 times 43 plus 1, 86 plus 1 is 87. And so it works. Okay. All right, here, so I'll even go ahead and put in the 0 here. So 1, 2, 3. All right, so stage 1 has 6 snowflakes. Stage 2, you can see 3 more were added, so it now has 9. Stage 3, 3 more are added, so it has 12. So we notice that we are going up by 3 each time. So if we go backwards by 3, that starts us off at 3. So the equation is 3x plus 3. This 3 comes from adding 3 each time. This 3 is because that's our initial value when x is equal to 3. And again, you can see if you go backwards to stage 0, you've got these 3 snowflakes. And again, just to check, let's see, y equals 3 times 43 plus 3, y equals 129 plus 3, which is 132. So that works. Okay, so this would be the equation for that. All right, puppies. All right, so stage 1, 2, 3, 4. All right, so stage 1 has 1, stage 2 has 3, stage 3 has 5, stage 4 has 7. So we are adding 2 each time. So if we go backwards and subtract 2, that puts us at -1. So the equation is 2x minus 1. The 2 is because of the plus 2 right here, and this minus 1 is because of this right here. So we have 2x minus 1 equals our equation. And then let's see if it works. And it does. Y equals 85. Okay? So you're also going to have to be able to do the same thing with just looking at x, which shouldn't really be too big of a deal. Again, y equals mx plus b. The m is what you're doing every time. So if you notice, this is going up by 4 each time. So therefore, the m is 4. The b is when x equals 0. So the b here is 6. So when you put this together, you have 4x plus 6. Okay. Here's another one. So this one is going, oh, this one is not linear. Oh, no. Okay. I'm looking here at these numbers and notice that they're not all here. So let's do this. So okay. So hopefully you notice that you are subtracting 4 each time. So you don't really have to do this to fill in the rest of this table, but I just wanted to make a point here. So if I'm subtracting 4, that means I'm adding 4 if I'm going the other direction. So this is -6, this is -2, this is 2, 6, and then this is 10. So that takes care of all that. All right, so in the equation y equals mx plus b, the m is what we're doing each time, and we are subtracting 4. Because it's about going this way. So we're subtracting 4, so -4x, and then plus 6, because when x is 0, y is 6. Okay? All right, so the worksheet that you're going to complete is on this stuff right here. Again, come see me at 12 o'clock for a live session or email me with questions, and I want to help you, okay? All right, bye, guys.